Hello and welcome to the next episode in Rust. Now, I know a lot of you are thinking, Merrick, we haven't really covered how to store complex data. We've used integers, we've used strings, we've used those types of things, but we really need to represent data in a better way because we want to represent something a little more complicated. And that's where structs come in. Now, obviously, there's more uses than just holding complicated data, and we'll get into those in the future, but yeah, we want to maybe store a string and an integer together, like my name and my age. So let's have a struct that represents a person that has their name and age. So let's go ahead and jump in here and do that right now. In Rust, it's really, really simple. All you do is struct and then the name. So we'll call this person. And yeah, well, we need two fields. So we need a field called age, and we'll make that an int, I32. And then we need their name. And, that's going to be a string. So this is the basics of a struct. You have the name of the struct, and then you have the things that it holds. We have the properties that it holds, the age and the name. Now this is really cool, and we can go ahead and create this structure in our main program here. And this is how we use it. We're defining a variable name, I just called it Merrick, and it's of type person. And then we fill in the information as we go. This works really easily, really nice. And here we've used our new struct to hold some more complicated data types. Now this is great and all, but what if we wanted to create some functions that actually operated on this? So these are classically called methods. I don't know if you all know the difference between a function and a method, but usually a function doesn't operate on something and a method is tied to an object, a struct. So let's actually make something, let's make a function that creates a new person with the name and age. It's a nice pattern that exists. So let's do that right now. The way you do it in Rust is a little different than you would in a language like Java or C#. In a language like C#, you would make the new function here. You would start to define a function here. That's not the case in Rust. In Rust, you're going to make a new impl. So it stands for implementation. You say impl, then you say what you're making an implementation for, and we're making an implementation for person. Now in here, you can define new functions. You can define things that are actually methods. These operate on a person. So let's make one now. Let's make one that just returns a new person. Now, inside an implementation, you can use self as a type. You're saying that you're returning your type, yourself, as a type. So here we're saying we're returning a new type of person. To make this function actually useful, let's actually let it take in arguments of age and name. And then down here, we can just go ahead and pretty much do what we did originally. We're just going to return a person. And we've done it. We've created a new method. Now you'll notice that this method this is actually just a friend function. It's not really a method. It doesn't operate on any data held by your person. And this is okay. This is fine. But we can now use this like this. So to use this new function on a person, it's actually quite nice. And this is how we can go ahead and use it. We can say, let John, we're going to have a new variable named John. Let John equal person new. And this is the function we've just made. You can see Visual Studio Code already knows what it is that it's looking for. We need an age. We're going to make them, they're a little bit older, 51. Their name is obviously John. And there we have it. So this is actually really nice and a nice way to make and use these things. So I really encourage you to leverage this type of thing. Now, again, we want to be able to increment their age. So every single year we want a function called birthday, and that birthday is going to increment their age. So to do that, to be able to make operations, we need a function method. Now, before we work on something that mutates internal state, which is a little bit different, let's do something that just uses internal state. That's a little bit easier. So we're going to do a function. We're just going to do a getter. These are private, so outside of this file, you couldn't use age directly. So we'll do a get age function. Get age. And this doesn't take any parameters except it does take a reference to self. And it returns an I32. All right, so here we have a function that takes this. This is a little bit of a special word, and it returns an I32. So let's go ahead and give this a try. We can just type in self.age. And that's all this function is going to return. It's just returning the age of the person. Well, cool. So this is how you create a real method. This is a function that works on this. So now, if we wanted to print this out, all we have to do is go let John's age equal John.getAge. And there you have it. We're using this method on John, on this, which is a type of person. Okay, so that was quick. That was easy. That's just how easy it is to do this. Now we want this birthday function. We really want this birthday function. How do we do it? All right, so one of the things that you're going to be tempted to do is mutate state. Now, mutating state has its problems, and because of that, Rust does its best to protect you from improperly mutating state. But we want to do it anyways. All right, you guys have been getting used to this mutable thing, telling you that you want to mutate something. And the really cool thing about this method here is that this is going to say that I need a mutable reference to self. So check this out. If we want to call birthday on John here, watch this. John.birthday. And it's going to complain. Cannot mutate immutable variable John. So you didn't take it as mutable. This is one of the things Rust is doing to protect you. You didn't say that you were going to have a mutable John. Let's fix that. Now we can mutate John's state. That is super awesome. And the reverse is true too. If we're down here in our birthday method here, and we don't declare this as mutable, it's not going to let us mutate state on John. Again, it's not going to let you do something that you didn't mean to do. It's forcing you to be explicit, which is always a good thing. Which is almost always a good thing. Almost. This is the basics of structures. I'm trying to keep these super short, so I just have a few extra points I want to point out, and then I'm going to send you on your way, and next week we're going to be talking about enums. Another simple lesson, but enums are so powerful, we'll get into it. Rust has this idea of tuples, and so you can, or tuples, I've heard them both ways. I actually say them both ways depending on the last time I heard them spoken. Rust has this idea of tuples, and it's really quite interesting the ways that you can do it. One of the classic ways is to define a point. So we could do like a point 2D. And a lot of the times you would see somebody do this. Struct point 2D, and we'd have an X, and we'd have a Y. This is not bad. This is not bad. But in Rust, you can do this a little bit simpler by doing something like this here. And we'll just call it point, because obviously we can't call it point 2D. We'll call it point, and we'll just make this a tuple. I32, I32. Now, this is effectively the same, and there's a couple things that we can do with it, but you can create one of these points just like you would a person. And the other thing that's interesting here, so if you wanted to create one of these, you could do this. You know, let p equal point 20, 20. And you just created a point at x of 20, y of 20. But you can also then go ahead and create methods on this just like you would any other struct. You can make an impl on point and go ahead and make all of the methods you want. You could even make a get x and get y a method. So cool. There are a few other really quick things here. You can do something called blank structs. So you can do a struct that has absolutely no data. So you could do a blank struct like this. Let's do struct. It's a Merrick struct, and it's absolutely blank. It doesn't have any extra data. And you might be thinking, why would ever I want to do this? Well, there's a couple reasons. It's a great way to group some methods or functions on this type. It's an empty type. Now, I think you can abuse and use this, but I'm just giving you the knowledge so that you can see it and understand it and know what it is. But there's one last thing that you can do if you're wanting to kind of make a complex type. So for example, you want to make a hash map of a very specific thing, and you want to reuse that a lot. It might make sense to make a type of that. Now, you could make a struct that has that, but you really are just making a very specific type of a generic. And the easiest way to do that is just to type the name of the type. We're going to make this it doesn't matter. We'll just call it special hash, SP hash map, because it's our special hash map. And that is going to be a hash map of, we'll just say it's a hash map of string. And I know we haven't talked about generics just quite yet. I just wanted to throw this out there so you guys could see it. This is just always this. It's just making a complicated type out of a generic and making a maybe more easily reusable name. Now, again, I wouldn't get out of hand with how often you use this. Now, another thing that I thought would be good, actually, my people on Twitch chat thought that would be really good, was just talking about how you refer to your own structs inside of the struct itself and how that can get really complicated really quickly. We're going to talk more about how to reference yourself and how to deal with self-references and lifetimes in the future so that it becomes second nature. But you can get into a little bit, it can be a little bit difficult, especially if you're wanting to have, let's say you want the person, the struct person to have a reference to a dog, but that dog also has a reference to their owner, which happens to be this person's, and you get cross references. And with memory leaking, like I said, it gets a little crazy. So if you're trying to do something like that, wait for a future lesson, because that's going to be a little bit more advanced. So just be careful when you're doing that. That's you're doing it at your own peril. The other thing, really quickly, before we go, we talked about tuples, but you can just use tuples right inside the main function here. Instead of making this point tuple, you could say, let my point equals 2020. And this is effectively the same thing, although we could have methods on this, and this is just a tuple, and you can only ever access it like a tuple, but this is still viable and a reasonable thing to use in some cases. All right, that's it for me today. I hope you liked this really quick lesson on structs. Gonna try to get these things out as fast as I can so that you guys can all learn Rust with me, because it is a fantastic language. I really haven't touched a language that's quite as fantastic. I really do like it. And so I want to try to help some people get onto it. We're really close to being done with these introductory ones and really going to get into some more advanced ones where we're actually building some projects. So if you're liking these, please leave me a comment, leave a like, and let me know that you want to see more of these. And I'm going to continue doing them. So thank you very much. I'll see you in the next one where we go over one of the best features in Rust, enums.